Hello, good evening all. Can you hear me? Can you hear me? Am I audible and visible? Okay, okay, great. Let us wait for 5 minutes and then we will begin. Good evening. We will begin in 5 minutes. Let us wait for others to join. Today we'll be covering the word semantics and from the Python implementation point of view, we will cover the various text similarity measures, point-wise mutual information, and word to vector model. Like there are several models that are used for obtaining the word embeddings. So today we will be having a look at the word to vec model that is very popularly used in the past days. Now several other recent advanced models have come up, but if the time allows we will see them also towards the end. Okay. And as for the session of the previous week, that session soon we will have this week. We'll let you know when there will be an announcement on the portal when that session will be conducted. So we'll also cover the numericals related to MST parsing in that session. But today we'll be having a look at the word semantics part. Okay. Let us wait for 2 to 3 more minutes and then we will begin. So I hope all of you have watched the lecture videos related to word embedding distributional semantic model. Have you? Have all three of you watched? Four of you? Because if you have watched, then it will be easy to follow today's lecture. That is the only concern.
Yes, ma'am.
Okay, good. Also, I hope you are submitting your assignments in time. This week's assignment was okay, like easy only. So, were you able to do it? Or there is still time to submit it? Think there must be time to submit it. Okay, then let us wait for just 2 more minutes and then we will begin. So, what is Euclidean distance? Anybody? What is Euclidean distance between two words or two sentences? What is the formula? And what it is also known as? What is the other name for the Euclidean distance? Anybody? Please let me know if anybody of you knows that. Let us begin now. Just a minute. Can all of you see my screen? Can all of you see my screen, students? Please let me know.
Yes, ma'am.
Okay. So, good. Okay. So, what is the difference between the formula of the dice similarity and the dice index and the Jacquard coefficient, Jacquard similarity? Please interact. It will be easier to make you understand the concepts and discuss if we interact with each other. What is dice distance? There is a question in the assignment also not related to that. What is the dice distance? Anybody? Alok? So, anybody, please let me know if you know what is the difference between the dice distance and the Jacquard index. It is very important to have a good hold on these distance similarity measures, text similarity measures, because they form a crucial part of your application, NLP tasks. So, I'll write two formulas. Please let me know which is which, okay? So, today is week 7 and we are covering the So my first question was, what is Euclidean distance? So anybody knows the formula for Euclidean distance? We have also studied in maths class in plus 2. What is it? Say x and y are 2 points and I want to go from okay x1 y1 to x2 y2. Then what
X1
is the
minus
distance?
x2 whole square plus y1 minus y2.
Sorry, could you please speak a bit louder? What is the
X1
distance?
minus x2 whole square plus
Yes,
y1 minus y2 whole square.
x2 minus x1 whole square plus
All
y2 minus y1 whole
the
square.
between the two Euclidean points.
Yes, yes. So Euclidean distance is also known as L2 norm. Okay. This question can be asked, what is the other name? Or in the question, it will not be given to find the Euclidean distance. They will say find the L2 norm between so and so points. So you should remember that L2 norm is nothing but the Euclidean distance. Okay. Is it clear? Is it clear to all? Is the same as L2
Yes,
norm.
ma'am.
Okay. Good. Very good. So, for 5 to 10 minutes in the beginning, we will revise these points and then we will have the look from the Python implementation point of view. Okay. Then, next comes the dice coefficient. I was asking you, and the shorter the Euclidean distance, the better it is. Okay. Also, remember this point. The shorter the Euclidean distance, the better it is. Can anybody tell why? Can anybody tell why so? Is this statement correct or not? And if yes, then why? What are your thoughts upon it? Is this statement true or false?
I think the less the Euclidean distance is, more the words are similar with each other. Is it correct?
The more the distance or the lesser the distance?
The lesser the distance, the more the words are similar to each
Yes,
other.
that's why we are saying it is better. Okay. I hope you
Yes.
understood the analogy, right? So here, what you could say here, the points will nothing but the different words that comprise your sentence. Okay. So say W1 and W2 are in sentence one, and W2 and W3 and W4 are in
Sorry to
sentence.
interrupt you, madam.
Yes.
Your voice is not clear, madam.
Okay.
Madam, your voice is not clear.
Just a second. Let me check my internet connection. Is it because of the connection or anything else?
It is clear right now, madam.
Okay, okay. Maybe
It's clear, ma'am. Clear.
so maybe internet
Yeah.
connection issues are there. Please let me know. I'll repeat that particular point wherever it gets stuck. Okay. Okay. So here, when we are talking
Okay,
about
madam.
the Euclidean distance in terms of points, it could be here the
Really?
points could refer to the different words in the sentences that comprise the document. Okay, in case of NLP. Okay, and the shorter the Euclidean distance, the better it is. Why? Because then the two snippets of text are said to be more similar. The two texts are similar to each other. Okay. Okay. Then what is the dissimilarity? What is dissimilarity? So we have two similar concepts. Dissimilarity and the formula looks very similar to me. I don't know if it looks similar to you as well. So let me know which is which. So A intersection B upon A union B. The cardinality of it. Say A is first sentence, B second sentence. Okay. Then how many words are common between the two sentences upon the number of the total words in the two sentences. Okay. So this is your Jacquard similarity. What should I add in this to make it equal to the dissimilarity? Anybody? What is dissimilarity?
In the numerator,
Mm-hmm.
multiply A intersection B by 2.
Yes, correct. 2 times A intersection B upon A plus B. Okay, correct? Is it okay?
Yes, ma'am.
Okay. Understood? So Jacquard similarity is also known as what? It is also known as intersection over union. Simple mathematical terms. This is the intersection operation we do in the sets, Venn diagrams sets, right? Intersection upon over union. So sometimes it can be asked, find the intersection over union, and it is written as I small o and capital U. Intersection over union. So that is nothing but they are telling you to find the Jacquard similarity. Okay? Clear? Is it clear to all till this point?
Yes, ma'am.
Okay, great. Then what is L1 norm? What is L1 norm? What is L1 norm? L2 norm is what? L2 norm is which distance? We just saw in the first slide.
Euclidean distance.
Yes. So then what is L1 norm? Any idea? I think I covered it in one of the classes. Is it the Chebyshev distance? Just think for a minute and tell.
Mod of A minus B plus mod of C minus D.
And what is A, B, C, and D?
A and C are the coordinates of one point, and B and D are the coordinates of another point.
So A and
A and C are the coordinates of
first point and
X and Y coordinates of one point, and B and D are the coordinates of second point.
so you are saying L1 norm will be equals to A minus B
Mod of
plus C minus D,
C
right?
minus D.
And
Yes.
similarly, we want to calculate the L2 norm here, what it will be? Can you please help me with this also?
Square root of A minus B
Yes.
whole bracket square plus C minus D whole bracket square.
Correct. Understood all of you what is L1 norm and L2 norm. Okay. So this is the sum of the absolute distances between their respective coordinates, between their x coordinates and between their y coordinates. First we take the difference. So it is nothing but this term. See, L2 norm, square is coming, right? And then square root is coming here, power 1, right? Okay. And because here we are taking the square, that is why we are not applying the modulus operator here. Because anyways, if any negative number is there, if we take the square, it will become positive only, right? Say A minus B gives you the value minus 2. Minus 2 whole square is also 4 and 2 whole square is also 4. That's why we are not applying the modulus operator here. Clear to all? So what is L1 norm known as? Is it the Chebyshev distance? It is known as the
Manhattan distance, ma'am.
Yes. Sorry.
Manhattan
Yes. You can say
Manhattan distance.
yes. You can say Manhattan distance or chessboard distance. Both is fine. So why I am telling you the alternate names? Because in the exam they can give you calculate the Manhattan distance. Then do not get confused what they are asking you to compute. Okay. Manhattan distance. Chessboard distance, why? Because if you have to go from this point to this point, then what is the difference you are taking? Okay, that way you can assume A comma C and B comma D like this. Okay, okay, chessboard or the Manhattan distance. Chebyshev distance is different. Okay, so now let us have the look at different distances. And you know, all of you know what is cosine similarity? That is the most important metric that we are going to look at. What is cosine similarity formula? Between points A and B. What is it? Modulus of 3, right? Is it correct, or I should write whole square? What is the correct formula of cosine similarity?
Need not write whole square, no ma'am.
Why? I'm asking you. I'm not sure. I'm asking you. What should I write? Think and tell. Who all think that there should be a whole square? I'm asking you. Please tell. Please help me. What is the cosine similarity formula? Is this expression in the denominator correct, or I should modify it? Hmm?
Modulo A into modulo B.
Yes. That's why I am asking. Please tell. So this is A into B, magnitude of A into magnitude of B. Okay? Let us see how does this apply to NLP. What is A, what is B? Okay? So say A and B, these are two sentences. So let us see with the Jacquard similarity. Okay? I hope my screen is visible to all of you. I'll just increase the font a bit. Is it better now? No, it is too much. Is it better now? All of you can see it? Can all of you see? So what?
Yes, ma'am.
Okay, great. So we said in Jacquard similarity, what is the formula? We read it as intersection over union, A intersection B over A union B. So we have two sentences here. Say A is the first sentence, I like dogs. And second sentence or document 2 is I hate dogs. So what we are doing here, basic pre-processing NLP steps, we are doing the lowercase, because here the word I is similar, right? But in another document, this can be capital, this can be small, but it does represent the same word. So we are just doing the basic pre-processing steps. We are doing the lowercasing, and then we are splitting them into tokens, splitting them, taking the delimiter as the space. Okay, so how many tokens will I have in the doc 1? How many tokens will I have
3.
after splitting by
3.
space?
3.
3. And what does set means? Say if I appeared 2 times in this document, I like dogs. Say it appeared two times. Say like appeared 2 times. I like dogs and rabbits. I like dogs and I like rabbits. So it will take only I like dogs and rabbits. Why? Because set is only used to take the unique tokens. Okay, we need not take the same token in this sentence again and again. Okay, similarly, so therefore we have used set here. Okay, and in the second document also we have applied the same procedure, and then we are printing the tokens in both the documents. What does it appear like? Dogs I like, I hate dogs. Okay, so we have printed the tokens. And now to calculate the Jacquard similarity, what I am doing, because I am taking here, as I have written, you can clearly see, I have written the cardinality. That is, I am taking the length. How many sentences are common in sentence A and B? Or how many tokens are common? How many are common in A and B? 2 are common. I like, or only one is common? 2 are common. But those common
I.
tokens are I and dogs, not I and like. Okay? So what do we have in the numerator? What do we have in the numerator?
2.
2. Not I and like, but how many what is the length of the tokens that are common. Okay, intersection, as I said, it is also known as intersection over union. The why? Because we are seeing that we are applying the mathematical set operations. Why? You see, we took the set and then we are applying the set operations on them, right? So we are taking the doc1 tokens intersection with doc2 tokens and then union and then their respective lengths. So it is 2 in the numerator and 4 in the denominator. How 4? Because A union B, that is I like dogs, I hate dogs. Total 6 tokens you have in the numerator, in the denominator after union. But since we are only taking the set, right? So it will take I like dogs, hate. So 4. 2 by 4, 0.5. Understood, all of you? Why we are getting 0.5 here? Is it clear to all?
Could you please tell again, ma'am, please?
Okay, sure. So, which point do you want me to repeat? The entire thing or a specific point?
The last one alone, ma'am. The calculation of 0.5
Okay.
alone.
Yes. So, see here. What we are doing, let us print this, okay? Let us print and check whether what I am saying is correct or not. So, we are printing. What does intersection give you? The tokens that are common, right? Is it right? The tokens
Yes,
that
ma'am.
are
Yes.
common in the first sentence as well as the second sentence. Which two tokens are common? I and dogs, right? So in the numerator you have 2, right? And in the denominator what you will have? I like dogs, hate, right? In the union. You know how to do the set union, right? We only take the
Yes, ma'am.
non-repeatable items, right? And we club them together, है ना? So how many items you will have in the denominator? 4. I like dogs, hate, right? So 2 in the numerator, 4 in the denominator. 2 by 4, 0.5. Also you can see here it will show like this only. Clear? And you
Thank
can
you,
also,
ma'am. Please.
yeah, you can also print them and check which are common, which are what is we are getting on union. Print. Okay. See, I hate like dogs. Clear? Why we are getting 4? Is it clear to all of you? Any doubts to anybody? So what will be the dice coefficient here? What will be the dice coefficient here? Think and tell. What will be the dice coefficient value here? Dice similarity. 0.5 is the Jaccard
4
similarity.
by 6.
Huh?
4 by 6. 4 by 6.
4 by 6 or 1? How many of you say 1? How many of you say 4 by 6? How 6 in the denominator?
Ma'am, numerator 2 into A intersection B by in denominator A plus B, right?
Uh-huh.
So, therefore, it is 4 by 6, correct?
A plus B. So A plus B is what? A plus B is not A union B. A intersection.
So then 4 by 4 will be 1, right?
Mm-hmm. Let us check. Just a second. I think you are correct only. because it says it cannot be greater than 1. It ranges between 0 and 1. So, yes, you're correct only. It will be 4 by 6. Okay? Did all of you understand how we got 4 by 6? Any doubts? Any doubts? Just a second, let me see if we can do it using Python also. Just a second. So let us do the bag of words representation for this. So do you know what bag of words is? Anybody knows what bag of words is? If I want to write here the bag of words representation and then do it, how can I do? Say my vocabulary comes out like I like dogs, hate. So my sentence one was I like dogs. Sentence 2 is I hate dogs. Can anybody tell what should I write now corresponding to this, the bag of the words representation or one hot encoding? Any idea? So let me give you an alternative way how we can do it. Say we write all the unique words in the vocabulary. Then we see which words appear in the first sentence. And if they are present in the vocabulary also, we write one corresponding to them. So is I present in the first sentence? Yes or no?
Yes.
So we write 1. Is like present in the first sentence? Like is present. So we write 1 again. Okay? Oh, sorry. Not here. So we write 1 again here. Then dogs is also present, right? We write 1 again. Is hate present in the first sentence?
No.
So we write what? 0. Okay. So this is known as what? One hot encoding. So whatever the unique words are there in your vocabulary is like all the sentences in your data. Okay, here we had only 2 sentences, therefore I like dogs hate. So we took four of them, and then we are representing them by the one hot encoding. So what will be the correct representation here? Can you please help? Write according to this. So I is present. What do I write?
1.
Hate is like is present in this sentence.
No.
So what should I write?
0.
0. Then dogs is present.
1011.
1011. Understood?
1.
Now what you can do, you take this representation. You write here 1, 1, 1, 0. And then in the second, this is an alternative way. You can also pass strings, but since I wanted to tell you an alternative way, we can also do it like this. Okay, it will give me error because of this. So we are getting 0.333. So 4 by 6, 2 by 3. We are not getting that answer. Somebody said no, 4 by 6.
Yes, ma'am.
Okay, we can check this why we are getting 0.33. Okay, please check it. Okay, even if this order changes, the similarity will still come out same. See, some of you wrote like your vocabulary order like I hate dogs like. That will not change because the number of the ones and the zeros are not changing right here. Or you can check if it changes or not. Okay. Okay. Is this point clear? How to calculate the dice distance? What is one hot encoding? This is just an additional point. May not be asked, but just for your reference. So how to calculate the dice distance? We have used the SciPy library here. Okay. Clear? Shall we move ahead? Is it clear to all? Or do you want me to repeat? Okay. So moving forward, how to calculate the cosine similarity. So say now we have two documents. What was the formula that we have seen for the cosine similarity? A dot B modulo of A into modulo of B, right? Magnitude of A into magnitude of B. So A is the first sentence and B is the second sentence. So let us see what is the first sentence. We have written I like apples, and the second document is I like oranges. So how we are calculating the cosine similarity between them? Doc1 dot similarity with the doc2. Okay. So what does it come out as? 0.93. I can run it again to show. And say you wanted to do this for your original sentences. What were the original sentences? I like dogs and I hate dogs, right? So let us see what does the cosine similarity comes out between them. That is 0.8323. Okay. If you change the sentence, it also changes. Now, if we want to do using the SciPy library, how we are doing? We are vectorizing the document. So, what does vectorizing the document mean? Same thing that I told you earlier. If you print doc1 and you print doc2, let us see. Vectorization is nothing but converting the string of words into numbers. Okay, this is using some this is using the NLP's inbuilt library that we have used from Spacy NLP, and we have loaded the English model. So using that, it is converting it into the vector, that is converting this sentence into numbers, and you can see what is the dimension of this number. You can also print it. Print type of doc1 and you can also print. First let us print the type and then we will see what type it is, and then we will print the shape. So it is a NumPy array, so I can easily print the shape of it. So print doc1 dot shape. So it will give me the what shape it has. So it is a 96 dimensional vector, and after it is calculating the distance, then it is printing. Okay, is it clear? These are the two different ways to calculate the cosine similarity. But you see, whether you use this doc1 dot similarity, doc2, for I like apples, I like oranges, the value comes out as 0.9309. Or if you use the SciPy library, still the value comes out same. Okay, there is no discrepancy in that. Is it clear to all? Any doubts? Text similarity measures are very important. Lot of questions can be asked, and it is just directly formula based, free marks question. Just apply the
Ma'am,
formula,
I
get
have a
mark.
doubt.
Yes, sorry.
I have a doubt.
Yes, please go ahead.
Madam,
Yes,
you have done this for English language.
yes,
Can we do the same for other languages?
yes, you can do. Just you need to load the different models here. Like I am loading the English model here, right? You can load your language specific model if it is if that language is present in the Spacy library. Okay, and if it is not present, then
Okay,
there are
ma'am.
several other libraries that support a variety of other languages. So you can take the help of those libraries and convert your sentences into vectors, and then however calculating the similarity formula remains the same. Okay, just what model you are using to load that sentence corresponding to the language in which it is written, that only will change. Okay,
That means only the second line will be different.
yes, yes, irrespective of that the
And
formula remains the same. Okay.
uh, mm, and one more question.
Mhm.
Is it necessary to remove the stop words before checking the similarity between two documents?
No, I didn't remove here as of now, but yeah, it is a good practice if you do, because there are some advanced models in which you need not do, but yeah, it is always a good practice to remove them, because they are not anyways adding any meaning to your document, right?
Okay, ma'am. Thank you.
Yes. Any other doubts to anybody? Please ask before moving ahead, because now we will build a search engine using these similarity metrics, so as to help you and realize the value of studying these similarity metrics. Just explain.
Ma'am, I have one
Yes,
doubt.
yes.
Uh, what is the difference between a bag of words and a co-occurrence matrix?
So co-occurrence matrix is, like you say, you plot the entire vocabulary of your words, है ना, and which word co-occurs with the other word how many number of times. Okay, and bag of words is how many times that particular word is occurring, right?
Okay, ma'am. Thank
Understood
you.
or not?
Yes, ma'am.
Okay, or you want me to explain again? I hope you understood. So co-occurrence
Yes.
matrix is, say I have two words W1 and W2. How many times these I have n documents. In how many documents these two words are appearing together. Okay, that value I will put in the cell of W1 and W2, right? But in the bag of words, how many times the word W1 has occurred in the entire document that I am processing. Okay, or how many times the word W2 has occurred, so that will be the bag of the words by frequency. Okay.
Okay, ma'am. Thank you.
Any other doubts? Just a second before we proceed ahead. Okay. So now we will see how to use this similarity matrix to build a search engine. Say I have inputted one sentence to the model, and now I want the model to find out top 5 similar sentences to a given sentence. How does this help? Say when you are writing some article, or you have typed your query in Google, what does Google do? It matches your search query to whatever the documents it has in its database. It calculates the similarity between them, and then it gives you the top n documents that are more similar to your query. Is it okay? Is this point clear to all? Say I have typed a query to Google, what is bag of words? Okay, so Google has 5 documents. Google has hundreds of documents in its database. Some are related to NLP, some are related to sports, some are related to news. So it will calculate the similarity of my query, what is bag of words, with every document. Okay, then it will see how many with how many documents I am getting the highest similarity. Okay, it will calculate the similarity between what is the bag of words and document related to sports, document related to NLP, document related to, you know, uh, what sports, NLP, and say deep learning or any other. And then it will sort these documents in the descending order of their similarity scores, and then it will give me those documents with which my query, that is what is bag of words, is having the highest similarity with. Okay, that is what we call as the search engine. That is how Google works in a, if I want to give you a very broad overview. Okay, is it clear to all what is the real life implication of this calculating the similarity matrix? Any doubt in this?
SEO, ma'am. SEO is the real time application, no?
Sorry, SEO, I didn't understand. Sorry, could you please repeat?
You asked for that real life implementation.
Yes.
Search engine optimization all is done based on this,
Yes,
right?
yes, yes, you can say to some extent. Yes. So let us see a very basic example of what I just said. So what I have done, I have imported the basic documents, like the basic libraries that I would be needing. This is used to calculate the norm, L2 norm, or you could also use some other distance matrix. Okay, and I am importing the libraries NumPy, Pandas, and loading the English language model for the from the Spacy library. And I'm also importing the dot similarity matrix, that is what is dot product. Which similarity measure is the dot product?
Cosine similarity.
Very good. So say I have created a list of documents. Okay, here I have created a list of documents. These are 5 to how many? 1 2 3 4 5 6 7 8 9 10 11. I think 10 to 11 sentences I have put into my system. Okay, I have prepared this data set. Okay, what are those sentences? You can have a read, and then I am taking the query from the user as input. Then what I will do, I will calculate the similarity score of the query with every sentence that is there in the docs list. Okay, and then I will store these similarity scores. Why we are vectorizing the input query? Because the model itself cannot understand the words directly. It always takes the input in the form of numbers. That is why we have loaded them with the NLP model of English language, vectorizing them, converting it into numbers. Just a simple process. Similarly, for every document you will do. Then what you are doing, you are calculating the cosine similarity between every query vector and the document vector. Document vector for every doc that is there in your doc list, and then you are storing all the similarity scores in the form of a list. Okay, after after this loop is over, how many similarity scores you will have? Any idea? What will be the length of your similarity scores list?
It will depend on the number of documents.
Yes,
That means
number of
number of
documents
sentences in our
in the doc list. That is basically it will depend on the length of the doc list, right? Then after that, after this loop is over, I have the all the similarity scores in the form of a list, right? Then what I'm going to do, I will sort them in the descending order, right? I will sort them in the descending order. How I am doing, I will just explain. And then I will print all the documents that are most similar. So for sorting the documents according to their similarity scores, we are using the function argsort. But what it does, by default, it sorts them in the ascending order. So with the documents that are having the most similarity to my query document, will they be in the beginning or towards the end?
at the end.
At the end. That is why I am taking from -5. From the bottom 5 till the end I am taking. Okay, I want to retrieve the top most 5 similar documents. Okay, and what it does is, say say you got the similarity scores uh, for top 5 documents like this. Or let's say I cannot do for 10 documents, I am just telling for random 3 to 5 documents. 0.45. So what it will do, argsort, it will sort them in the descending order. What will be the ascending order? What it will be? 0.4, 0.45, 0.8 and 0.9. But then it will give me their indices and not directly this list. So what it will give me, is this indices. So 0.4 indices for which document? First, right? Then 0.4 is 0.45 is the third document. Then please help. Then 0.8 is for 0th and 0.9 is for second document. It will give me the indices like this. Okay, and then I will print the document that is at this particular index. Understood? Understood or not? Did all of you understand or not? Is the concept clear? Shall we go for a demonstration of it? Okay, good. I can see some thumbs up coming. So we are asking for the query from the user. Let's say I will write, I like Indian food. So most similar, what according to what the system has computed, the most similar document is I do not like this restaurant, and what is the indices that it is giving. Then it has sorted them in the reverse order, and these are the most similar documents from the data that I have given. Is it clear? So do you want me to enter some queries? Does any one of you say some query which is little similar to the context that we have written here? Say some query. Please feel free. Yes, you can definitely take some data set of your own, and then you can iterate over this. Say you inputted some document and that had some paragraphs in that had a couple of sentences or a couple of paragraphs in it. There you should, instead of the doc list, you can just mention that document. Okay, and then you will get the most similar to it. Say you have different news articles, so article 1, article 2, you can stack them in the form of the list and then you can put. Okay, so say I hate burger. So what are the documents that it is giving? So most similar, if you see, it is giving I hate this sandwich, I love this sandwich, I do not like this restaurant. Understood? So it is little similar. It is the model is able to learn and to give it is giving you the similar results if your query is somewhat similar to the documents that you have inputted. If they are very very far away, then hence will be the result. Is this point clear till here? Different text similarity measures in Python, how we can use.
Ma'am, please once
Once
repeat
more.
once again.
Once more.
Yes,
So
yes,
any
ma'am.
any specific point you want me to repeat, or the entirety of it?
This tax similarity that you have explained in the last.
Yeah, okay, this point, right? So what I am doing, I have given the query to the system I hate burger. So what it will do, this is my query document. It will go to the data set. It will compute the cosine similarity, or you can use some other distance metric. For my case, I have used the cosine similarity. What I am doing, I have taken the query from the user as input. This is my doc list that I have, the data I have prepared that I have given as input. Okay. Then I have taken one list similarity scores that will store the similarity of the query with every sentence that is present in the data set. And why do I am here I am doing the vectorization, because the system cannot directly take the words as input. It needs to work on the numbers. That's why we are converting them into the vectors. For that we have loaded the English model from the NLP library. Okay, we have converted them into the vectors, and then we are calculating the cosine similarity of query vector with every sentence in the document. And then I'm storing the similarity scores in this similarity scores list. So say I had 11 sentences here. Now I will have 11 values in the similarity scores list that contains the similarity of the query with every sentence in this data set. Then what I will do, since I want to retrieve the most similar documents for a given query, I will sort them in the I will sort them, and then I will return those documents that are having the highest similarity. By default, if I use the arcsort function from NLP, it sorts them in the ascending order. So the documents that are having the highest similarity will be towards the end, right? So because, and I want top 5 documents, top 5 most similar documents, so I'm taking this -5 till the end. And how does arcsort works is, it will arrange them in the descending order of their similarity scores, but it will return me the indices. Okay. And then after it has returned me the indices, I will print the document at that particular index. Okay, is it clear now? So if my input query was I hate burger, so these are the indices that are having the similarity scores in the ascending order. Then we have sorted them in the descending order, and then these are the documents on those indices, most similar documents on those indices. Is it clear
But
now?
ma'am, but these two vector are not in ascending or descending order. I think so.
Which one?
8650.
So this is not, that's what I was telling. This is not the, similarity scores. This is the indices. I had explained here. Say the similarity scores value came out to be like this. For example, zero point 0.8, zero point 0.4, zero point 0.9 and 0.45. Arcsort will sort them in the ascending order. Okay. Then it will not return you these values, but it will return you the indices of these values. Zero point 0.4 originally was at which was the document at the first index, right? So it returns 1. Then 0.45 was in the original set was at which position? 0, 1, 2, 3. So it returned 3. Then 0.8 was at first 0th index. It returned 0. That is what the whole game is. It is not returning you the similarity values, but it is returning you the index at that which document is present. Okay. 0.9 is at the index 2.
Okay.
Okay.
Yes, ma'am. Ma'am, can we do this for the Hindi text or the
Yes,
Devanagari
yes,
text?
yes, you can do. Similar, same as I said earlier. Here you need to change the model from which you are loading, and then your input sentences will also change. Okay.
Which model is available for the Hindi and Devanagari? And it will process the Hindi or Devanagari
Yes,
as
yes,
well as means model take the value in numbers. So
yes.
we do vectorize. So how it will process?
It will process these libraries have already been trained on large corpus of these languages, right? We are not telling it how to obtain the embedding for I love this sandwich. The model is creating on its own. If you see here, I gave the sentence to the model as just I like apples, and I loaded the English model. But I didn't specify that you have to learn this 96 dimension vector. And I'm not fixing the values. The model has already been trained on a very large data based on which it learns to derive this vector. Okay? Similarly, it will do for the Hindi and English and other Indic languages also. Okay?
Ma'am, could you show the example of the other language like
Uh,
Hindi or Devanagari?
Yeah, I think you can refer to this link. I'll share the link with you because I have yet to cover the word to vec model in today's lecture. Maybe you can write back to me if you're not able to do it. But yeah, you can do it like this. Just a second.
Ma'am, so we would simply put the model, we simply load the model, it will process automatically by following the same process.
Yes, yes.
Yes.
So you can
Okay.
use the INLTK library, Indic NLP, Stanford Core NLP, or you could also see if Spacey provides support for Hindi language or not. I'm not sure because as of now I'm using the Spacey library. Load Hindi language model in space. So I think it provides, see, I am sending you this link. Spacey provides support for these languages, okay? I'm not sure. Let us check if Hindi is there in this or not. Bengali is there. So you can load the Bengali language model. Hindi is also there. Just try it once, okay? Just search in Google how to load the Hindi language model for, you know, Hindi language, and then try this same procedure and take the input as two different Hindi sentences or whichever language you want. Okay, these are the different languages that Spacey supports. So it supports Tamil, Telugu, Urdu, and Marathi, Malayalam, Kannada, Hindi, Gujarati, Bengali. Okay, please give it a try once. Okay, and if you are not able to make it work, let me know. Okay, is it
Okay,
fine?
ma'am. Thank you.
Yeah, okay.
Thank you.
Yeah. So shall we proceed? Any doubts? Anybody?
Ma'am,
Yes.
if you want to display the similarity measure
Mhm.
along with the sentences, can we do this?
So you want to like you want to see how what are the similarity values, right?
Okay.
In this.
Yes, yes.
Yes, you. I think that is pretty much easy. What you could do is np.arcs scores. No similar. Just a second. Let me see. So what we can do is we can directly print the sim scores dictionary, right? Sim scores list that has all the similarity values. है ना?
Madam, please share your screen.
Oh, is it? It is not being shared. It is being shared. How many of you
It's not
cannot see
visible.
it? Is it not
I
visible?
can't see it.
Okay. Let me share again. Just a second. If you cannot see it, let me just share again. From my side, it was being shared. Can you see it now? Just a second. Just a second. लूसी क्लास चल रही है. कोई बात नहीं. Yeah, can you see it now? Can you see my screen now?
Yes, ma'am.
Yeah, so what someone had asked me this query, can we see what are the similarity scores that we are getting? So we have the similarity scores with all the documents in the sim scores list, right? So you can just directly print this list, and you already have the indices which are more similar. So let us go and check at the 10th index. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 0.49. I think that is the highest similarity that we are having, right? Is it clear? 10th index.
Yes, ma'am. Yes,
Then
ma'am.
we
But
have 0th index 0.44.
I want to display the score in front of that sentence. How to do this?
Yeah, you can do that, right? Just need to modify here top index comma you just print it here itself. Top index, you want to print it in front of the sentence. So
In the for loop itself?
comma suppose let us see if we can do that. Are you getting it or not now? Like it changes in every run, so we can do it like this. Okay, is it fine?
Okay, ma'am.
Clear?
Thank you.
Yeah.
Yes, ma'am.
Good, good. I like this kind of interaction that makes me that helps me to understand whether you are getting it or not. Please do ask lots of questions. So any other doubts to anyone?
Ma'am, there is
Ma'am,
one more question.
Yes, please go ahead.
Uh, in our Google search engine, which type of similarity measure is used?
So exactly, I cannot tell what it is. It's I think it uses BERT model, if you are aware, bidirectional encoder representations from transformer. See, cosine similarity is a very basic measure, and I just wanted to help you understand the concept of it, what I was just going to explain. Okay, so I'm not sure which it is, but maybe I'll let you know.
Actually, I have learned that it works on the page, it uses PageRank algorithm
Yes,
to find out the documents which are
yes,
relevant to our query.
yes.
So, which type of similarity measure that PageRank algorithm?
That does not employ any similarity measure. That is a very different algorithm that operates on the incoming and the outgoing edges and dead ends. So that is entirely different concept. It is not related to it.
Okay, ma'am. Thank you.
Yeah. Yes, any other questions?
Ma'am, same. Actually, I want to ask this. There is any latest similarity major algorithm that we can apply
Sorry,
to our work?
is there any?
Latest, latest similarity measurement. Sorry, similarity matrix for finding the similarity.
So there are plenty. Like we saw Dice, Jacquard, Levinstein is there, Manhattan distance is there, cosine similarity is there, adjusted cosine similarity is there. See, by far, cosine similarity works pretty good in some of the scenarios. That's why I demonstrated it with that. But also, it depends on the nature of the task and the data that you have. So you can try with different measures and see whichever yields the best results in your case. So like you
But
can,
ma'am, dice, Jacquard, these all are the old, I think.
yeah,
The
these are
new.
all are old, but that doesn't mean they're not effective, right?
So there is any newer algorithm for this newer similarity matrix measurement algorithm is there that we can use for our
Maybe you can
work.
check. I'll also check and
Ma'am,
let you
Chat
know.
GPT all use the BRT and LLMs, right? Is that related to this anyhow?
Yeah, BERT is, but then that would be another thing, and I think it's beyond the scope of the discussion today. Yeah, you can definitely use BERT for getting the similarity scores. If you want,
Thank you,
I can
ma'am.
give you a link for that. Maybe you guys just check it out once, okay? Because lot of you people are asking these questions. I can give you a demonstration, but just go through this article as and when you have time. I mentioned BERT, by the way, in today's lecture.
Ma'am, word is also used for the classification purpose.
Yeah, BERT, right?
Yes, ma'am.
Yeah. It can be used for a variety of tasks. Let me just see if you can, it should be easy for you. Do you know what the working of BERT model? What is the full form of BERT?
Bidirectional
Hmm?
encoder
Hmm?
mm, transformer
Bidirectional encoder representation from
representation type.
transformers. So what do you know what a transformer is?
Uh, it consists of encoders and decoders.
Yeah,
It
that's
takes
correct.
it takes the input
Mm-hmm.
and then it creates a intermediate representation which is given to the decoder for decoding purpose.
Mm-hmm. So just a second, I am just finding some article that you can refer how to calculate the sentence similarity using BERT. Give me 2 minutes. Yeah. You can refer to this article when you have time. So I'm pasting the link in the chat box, and if you do not get any point of it, just let me know. We can have a discussion on this. Okay, shall I continue then in that case, or do we still have more doubts?
Is it similar to text summarization?
No, that is different. That is different. That's why I was not encouraging the discussion of BERT in today's lecture.
Okay, ma'am.
Okay, good. So, coming back to the scope of the syllabus, can you see my screen? So, what is word to vec model? Anybody? What is word to vec?
Each word
Words are
is
converted into
into
vectors, vector
vectors.
values.
Sorry, one person at a time. I cannot follow anyone. Yes,
Each
please.
word is converted into vector.
Okay. So, how? What are the two different submodels that come under this category?
Glow,
Anybody?
uh,
There are two very important models that come under this category. I think
continuous
it's
bag of words,
yes, and second one is
Skipgram.
Skipgram model.
yes.
skipgram,
What is the difference between the two? Skipgram and continuous bag of words?
One
surrounding
one target value is
Okay,
spreading.
you choose one. I am saying two. Okay, which stands for which you choose. So I have a couple of surrounding words and I want to predict the target word. So is it continuous bag of words or the skipgram model?
continuous bag of words.
And then what is the skipgram model?
One word is given, and based on that word,
I have to
the
find the surrounding words. So
surrounding word.
target is given in skipgram and you have to find the surrounding words. But in the continuous bag of words, you have the surrounding words and you are supposed to find a target word. Okay? Is it correct?
Yes, ma'am.
Okay. Shall we proceed? So I am taking some real data and will be training a word to vector model on that. Okay? Because basic analysis, how to find the synonyms, how to do the analogy, that I think would be clear to all. And even if it is not, with the help of this document that I will share today, you can easily do that. So word to vec model helps you to understand the analogy. Like if you give it three words like king is to man, so queen is to what? So what should be the analogy?
Woman.
Woman. Okay, good. So king is to prince, so queen is to
Princess,
Princess.
princess. Then India is to Delhi, so France is to
Paris.
what is the relation?
Capital.
Country capital, right? So like this kind of analogy word to vec can do, right? And it can also find the most similar words to a given word. It can find which words do not match to a given word. Okay, it can also find the most similar words and print their similarity scores. Okay, so just let me load the file, like it is taking time to upload. By that time, let us go over the basics. So here I have imported the regular expression for pre-processing, basic pandas library, time library for calculating how much time it takes, spacey library for pre-processing, and logging because we want to set up some values here. Okay, so I have read my this CSV file that is being still uploaded. So if you see here, this is the basic format to read a CSV file, right? What is PD here?
other another name for pandas.
Yes. So what do we call it as? Because I am importing it as a shorthand acronym, we call it as alias. Alias stands for name, also known as. Okay. in TV shows and everywhere you have seen na AK, also known as. So formal term for that is alias. Because I don't want to write pandas again and again, I'm using it quite frequently. That's why I've given it a short name. Okay. So then I am reading the top five. Df dot head will return you top and rows from this data frame, and then I am printing all the columns that are there, and I'm here taking only two columns to analyze. So what I'm doing here, from the entire data frame that I have a lot of columns, I'm just taking these two columns to analyze. What is the raw character text, like who is the speaker, who is this is from the particular TV show, that is Simpsons. You can see the name here, Simpsons. Can you see my screen, all of you? Can you see my screen, all of you? So if you are aware, there are several TV shows like Friends, and a lot of Hindi TV series shows are there. Similarly, this is one show, Simpsons, and we are just taking two columns to analyze here. Raw character text, like who is the character, and what is his dialogue, what is the word that he has spoken. So then because you can see here we are having some not a number null values, so we are dropping them from the data frame. My data is in English, so I'm loading the NLP model for English language, and I'm then doing the basic cleaning for this data, lemmatization, tokenization. And if length of any text is 2, I'm after removing the stop words, if the length of any text is greater than 2, then I'm joining them with the help of space. Okay. And then we are also doing some basic pre-processing, like removing the special characters, doing the lower casing and all. And then we are calculating the time that has taken to clean this data set. So my file has loaded, so I can run it and show. Till this point we will run. Okay. And then we will see. So here we are retaining only the alphabets, alphanumeric characters, and every other character we are removing. So it is calculating the time to clean up everything according to the pre-processing steps that we have written, that is lemmatization, stop word removal, not a number removal, retaining only the alphabets and all.
Ma'am, maybe may I know what we are trying to do with this, word to wake?
Yeah.
We
So
have taken some dialogues. Yeah.
I'm trying to train the word to vec model on this data set. Okay.
It's like word we are trying to convert into two vectors, like numeric
Yes.
format, right?
Yes.
So we are taking some dialogues from some episode or some show, and what we are going to do with that, ma'am?
Will convert them into the embeddings, that is the numerical vector representations, right? And then once we have converted, we will try to do the analogy, like the analogy king is to queen, prince is to what, that is already inbuilt in the model. But then this new data set come, you have seen na, in the lecture there was this one thing, out of vocabulary problem is there. So what you can do, you can train your word to vec model on a specific data set. Okay. So after that, we will do the analogies on this particular data set. Okay. So there are two characters like Bart and Nelson, how similar they are to each other, whether they like a particular person or they hate a particular person. That kind of analogy I'm trying to help you understand. And how you can train your own word to vec model given some data set. Static things so you can do, right? That's why I'm not taking that up. Is it clear? Is it clear?
Yes, ma'am.
Okay. Okay. So it is taking time to clean. Just a second. Just a second. हेलो हेलो, नमस्ते पापा। पापा ठीक है, मैं आपको आधे घंटे तक कॉल करूँ? मेरी ऑनलाइन क्लास चल रही है एनपीटीएल की। हाँ। So I hope it is clear. It is taking time to clean the data set. We shall move ahead. Once the cell is completed, we will get to know. So after the cleaning the data frame, we get the final shape as 59,520 rows. What was the shape earlier? Let us see what was the shape earlier. It is not displayed the shape here. Okay, anyways. Yeah, so there were 1,58,000 something rows, and after cleaning, you just have 59,000 rows. Okay, then in the Gensim is one library where you have the word to vec model, right? So from there, we will load this word to vec model. Later, you will see. But here we are just loading the phrases and the phraser that will give you, bigram and the trigram counts. So here we have loaded it. Okay, it took 4.09 minutes to clean. We've also dropped the duplicates here, and now with the rows we are getting, it changes every time, so need not worry about that. So let us see what this phrases is. We are just loading these models as of now, and we will use them later. What is bigram? Anybody? What is bigram?
Two words, two consecutive words.
Two continuous words.
Two continuous words. Always two continuous words? Always two continuous words or something else? So say I have a sentence like I love ice cream. So what will be the bigrams here?
I love,
Mm-hmm.
love I, ice,
Uh-huh. Ice cream, right?
then ice
Huh.
cream.
Will it be cream I also? Will it be cream I also? No, right?
No.
Okay, good.
No, no.
Okay, okay. So we have cleaned the data. Phrases is just to pick how many phrases you want to pick, and we are splitting every sentence. Row dot split. We are splitting every sentence in the our clean data set. Okay, this was just an example. So we have we can also display the word frequency. What is the frequency of different words that are occurring in this corpus? It says name sentences is not defined. Okay. Bigram is not defined. Okay. So see, if we want to sort the words with the order of their frequency, in the descending order of their frequency, how do I know that I'm sorting them in the descending order? Because I have set reverse equals to true. Okay. So I have so you can see, using the Gensim library, you can also calculate the frequency of different words that appear in your corpus. And now we will hear, this is how we are training the word to vec model. So this point is very important. Please pay attention here. What we are doing from the Gensim models, we are importing the word to vec. And then yeah, this is just if your computer is having more cores, you can utilize that. So what we are doing here, we are setting up the parameters for the word to vec model. Okay. So what is the minimum count or the minimum frequency that you want? And in some blogs it is this parameter is given as size. So make sure that you update it to vector underscore size, because this is the latest update. So what does this mean is, for every word that you have in your corpus, what will be the embedding dimension of it, right? If you remember, when we were doing with the spaCy, when we were doing NLP of some word dot vector, we were getting the vector of dimension how much? Do you remember? 96, right? I
Yes.
printed it also here. We were getting the vector of embedding dimension as 96. Here I am keeping it as 300. You can also modify it. But in most of the cases in Word2Vec, the authors in their research paper have said that they get the best results at 300. So I've kept it as 300. Sample size. These are some predefined parameters that you need to set. However, you can change and see at which parameters your model learns the best. Okay. And workers is scores -1. That is the course that you counted from here. Okay. And because as I said that your Word2Vec model may not understand the words that are outside your vocabulary. That's why we are training this model here on the specific vocabulary. We are building the vocab on the sentences from this corpus. And progress bar, like we will display after it has learned the embedding for every 10,000 words, and then how much time it takes to build the vocab, or how much time it takes to, then after it has built the vocab, like it has learned that there is this particular word in my vocabulary, then how we will train the model to learn those sentences. Okay, clear? Is it clear or not? If you have any doubt till this point, please ask.
Madam, please explain the Word2Vec model parameters. Parameters of Word2Vec.
These parameters are predefined. As I said, the only parameter that you need to take into account is this vector size. And as I said, in some of the blogs this is defined as size, but because of the latest changes in the library, it has changed to vector underscore size. So make sure to update it. This is the minimum count, like the minimum I think the minimum frequency.
Okay, ma'am.
Okay.
Only
And this
one
is,
parameter.
sorry,
We have to change only one parameter, that is vector size.
no, it is not that you have to change only this parameters. If you want to read the more details, you can just hover over your cursor here, and it will itself display the details. Okay.
Okay, ma'am. What is alpha, minimum alpha,
Yeah,
negative?
these are again the pre-trained parameters that you need to specify in the model. Why we are taking the window as 2? Because I have taken it on the bigram sequence, right?
Okay, ma'am.
So I'm setting up here the model's parameters, and after that we will build the model vocabulary on the sentences that we learned earlier using the bigram phrases, right? Sentences were the bigram of the sentences, right? So we are building the vocabulary on those sentences and how much time it has taken to build the vocab. And this is time to track the progress, how much time the model is taking to learn these new words. Okay. So say there around 2019 this new topic came up, COVID-19, work from home, right? Corona, है ना? And there were several different vaccines like COVID shield. So if you were to train a Word2Vec model based on you didn't train your model, you use the pre-trained Word2Vec model and told it to generate the embedding for the word corona, and then you calculated similarity with COVID shield, you will get its very low similarity, because the model neither knows the word corona, nor it knows China, nor it knows COVID shield. So it will give you very poor results because it does not recognize these words. These words are out of its vocabulary, out of our vocabulary. You say some word from Telugu language. If I am a person who does not know Telugu, I will say I do not know this word. This word is not in my vocabulary, right? So first we need to make the model understand that particular word. So that is why we are building the vocabulary in the first step. Is it clear?
Yes, ma'am.
Say if I want to write some essay and I want to use the word say exhausted, I should know in my vocabulary what is the word exhausted, what is its spelling, what does it mean. Then only I can use it in a particular sentence, right? Or I can understand what is its opposite, whether it is an opposite of active or it is a synonym to lethargic, right? If I do not know the word, if it is not in my vocabulary, I cannot be able to determine any of these relationships, right? So that is why first of all the first step is building the vocabulary, then it is training the model on this built vocabulary, right? Okay. So if you
Okay,
see,
ma'am.
after we have built the vocabulary, we are training the model on a particular data set. You need to remember this, that the example that I am giving you today is we are training the model on a particular data set. So first of all, we are building the vocabulary, then we will train. Why we are training the model on this particular vocabulary? Because the sentences comprise of the words from this vocabulary itself, right? Isn't it? Is it correct or not?
Yes, ma'am.
Hmm. So
Ma'am, how you create the vocabulary?
yeah, see, that's what I have been
So,
explaining so far. So we build the vocabulary based on the sentences, right? And in the sentences, we have taken their bigram occurrences.
Vocabulary is but the entire corpus,
Yes, yes. The unique words that
right?
appear in your corpus. So say we had two sentences. I like dogs, I hate dogs. So what will be your vocabulary? I, comma, like, comma, dogs, comma, hate. So your vocabulary is having the size of 4, right? Right or not?
Yes, ma'am.
Okay, good. So this is just setting up some parameters, and then we are building the vocabulary based on the words that you are encountering in the sentences. Then this is the most important step, how you are training your word to vec model. Once you have learned the vocabulary, built your vocabulary, then this is your input, that is the sentences that you are passing to the model. See, it is also showing here, transform corpus with 86211 items. It is not the individual word like oh, like, no, get, hey, think. That is your vocabulary. But your sentence will be like this: no, actually it this is your one sample. No, actually it was a little both. Okay. So it is total of 86211 sentences. Total examples is word to vec model dot corpus count. What is the corpus count? What is the vocabulary count of your word to vec model that you have trained? Epochs is when the model has processed the entire training data in its run, in its one run. And how many times you want this model to run is 30, and it will report the delay after 1 second. Okay, is it clear?
here corpus count matlab means vocabulary.
I think so. I think so.
Ma'am, I have one doubt.
Yes.
In continuous bag of words,
Mm-hmm.
uh, from surrounding words,
Mm-hmm.
one target word is found, right?
In continuous
So
bag of
here
words.
in continuous bag of words,
Yes.
that means here we require only one word as a target word, right?
Who said?
So
I'm
why are
not
you
giving you a
taking?
demonstration of continuous bag of words. I'm telling you how we can train an entire word to vec model.
Okay,
Okay.
Then why do we require bigrams here?
That was just an example to help you understand.
Okay, ma'am.
Just a second. Can we? I have not run this. Let me run it, and then we can see, because someone was asking whether what is the corpus count. I think it should be the vocabulary size. Let us see. Let us see. Let us print and check.
Ma'am, you have calculated the vocabulary using the bigram here, is it?
No.
So, means you find the size of bigram that was 4. You give the example.
I was just trying to help you understand that you can use how we can use the bigrams here.
So vocabulary is unique occurrences of word
Yes.
in the sentence.
Yes.
So it can also take the repeated word
No,
or
you tell
not.
me, if it is unique, should it take the repeated?
No, unique means one time.
Right?
Or
Right? You
yeah.
yourself have the answer to your question.
Yeah, okay.
Okay?
Okay.
So what vocabulary helps you is this way. While it is still running, I can help you understand. I like dogs and cats and rabbits. Okay? So say I will give it the index as 1. 2. Dogs I am assigning 3. And I am assigning 4. Cats I am assigning 5. So and should I assign 6 or 3 or 4 now? You tell me.
No, no, no.
You tell now whether I should assign it as 4 or 6.
4.
4. And rabbits will be 6. So you can also understand vocabulary is like a lookup table. As I already told you, my model cannot work on the sentences or the words, right? I need to convert it into numbers. So in the beginning, what I will do, I will assign it some indices, right? So every time my model looks at the word two, it understands, okay, two corresponds to the word like, right? Then we need not feed like into the model. If it is an occurrence 2, if it sees the index 2, it will automatically understand that this stands for the word like. So vocabulary is kind of a lookup table, okay? Like every word has a unique index, every word is unique, it is having a unique index. So if I am having a particular index, I can look up and see which word it refers to. Okay, is it
That
clear
means
now?
you are creating, madam. That
Hanji.
means you are creating this format 1, 2, 3, 4, 5, 4, 5,
No, no, this
right?
is again, see, listen, this is again an example to help you understand. The model is creating the vocab here, right? Okay,
O- Okay, ma'am.
this is to help you understand. Someone was getting confused. If the repeated occurrence is there, then how it will be assigned? What is vocabulary? I am using bigrams, and why vocabulary is coming up. So I hope now it is all clear. Even if I have used bigrams, then what vocabulary is? Vocabulary is kind of a lookup table. So you can understand it. It is like a dictionary. So where I is assigned 1 and like is assigned 2, right? And so on, right? Dictionary we have this values, right? Key comma value pair, right? So understood? Is it clear now?
Yes, ma'am.
Yeah, so corpus underscore count is how many unique sentences were there in your model. If you remember, after cleaning we had 86,211 sentences, right? So that is the total examples that you are having. Okay, and what is sentences? That we can print and check whether it is a bigram occurrence or what. Okay, it says it is a transformed corpus. It is some object, it is saying. So I hope it is clear. So now that your model is trained, then you can find the most similar words. Now your model is trained on a new data. So you can find what are the most similar words to a particular character Homer or a particular word Homer. Okay. So it says that Homer is more similar to G, quick, sweetheart, and it is also displaying their similarity scores. So once only you have trained the model on this data set, then only you can do this kind of analysis. If you change the words here, है ना, then if you want to find word to vec model dot wave dot similarity, what is the similarity score between these two, Maggie and Baby? These are two different characters, Bart and Nelson. What is the similarity between them? Okay, then out of these three that you have given, what is the odd one out character out of these? Okay, this kind of analysis you can do. Is it clear? Is it clear? If you have any doubts, please ask. I know it is a bit
That means
yeah.
Clear, ma'am.
that means it will check the similarity between the words which are present in our vocabulary.
Yes. Now say now you give it a new data set, that is a new TV show comes up. You train your own word to vec model, and then you see if it is able to give you the most similar character, the most similar characters to a given character or not. Okay.
Okay, ma'am.
And if you do not train the
And
model on your data set, then also you try to find the similarity by giving it two random words from your data. You will see once you have trained the model that similarity improves a lot as compared to this instance where you had not trained the model and tried to get the similarity score.
if I give the another name for the same word which is present in our vocabulary, that means if I give the synonym for any word which is present in our vocabulary, what will be the result?
If the word to vec model is already trained on that kind of data, it will be able to analyze because it has some it has already been pre-trained on some specific data. But then I am saying, if you have a new data of your own and then you want to find the similarity, then you can train the model and then you can get. And in your case, your question was you already have a synonym that was in your data, and word to vec model already knows. It will directly give you the similarity score.
For example, let us take one example. If my data contains one word, and if I give the another word which is similar to the word which is present in my vocabulary, so will it give the similarity score, or it will not be able to
No, see, it is present in your data, it is present in your vocabulary. But is the word to vec model from which you are trying to get, is it trained on it or not? That is what we are talking
yes,
about, right? Here,
okay,
both the things you are having on your own. We do not know what your model is trained on, right?
yes, yes, ma'am.
Yeah. So,
Um, Sorry, madam.
yes.
Suppose in my vocabulary there is one word like bag, and if I take another word like luggage, and if I try to find out the similarity between luggage and another word which is present in my vocabulary, will it give the it will it treat the same bag as a luggage?
That you can
Because
print and check, but I think you should frame your question in a better way. I earlier also pointed out, you should see whether your model is already trained on that data or not. And as for bag and luggage, I think word to vec model will be trained on this already, so it will directly give you the similarity score and how many words you are listing. Say you are listing top 5 words, so it will also give you some more words related to it. Like goods is also another words for luggage, right? So it may also give you that in addition to bag and luggage, right?
Okay. Thank you, ma'am.
Okay. So any other doubt?
Uh, Madam, there is one point in your Google Colab sheet,
Yes.
negative something.
Huh. Yes.
What is that?
So negative something is like these two words are having a positive relationship between them, right? And now I am taking a negative, that is Marge. I myself do, not know this, but I'll try to explain. Woman is to Homer. So, woman is to Homer. Homer we saw earlier that it meant that the person is kind or something, right? Kind or sweetheart. So, if a woman is sweethearted, so then Marge is some character. What is it like? Is it screw, effort, or attractive? So it's like an adjective or a characteristic kind of a thing.
Okay.
So this is a positive characteristic of a woman. It is that she is sweetheart. Okay. What is the negative characteristic of this Marge? Maybe Marge is not like full of effort or attractive, but it is saying that this is one characteristic and it is displaying the top three.
Okay, ma'am. Thank you.
Negative means, ma'am, in a negative way.
Yes, yes.
Okay. So if we write here positive in place of negative for the marge, so it will provide the positive sense.
I hope it does. Actually, I'm also not aware of this TV show Simpsons. If it were a show that I was aware of, I could easily tell you. So please look into this point again. I urge all of you to look into this point again. Okay.
Okay,
Parameter
ma'am.
positive.
But in general, it should provide the positive meaning for this word,
Yeah.
right?
Yes.
Yeah.
Yes. Maybe I'll annotate the notebook and send it to you when I am uploading. Will that be fine? Like I'll add an explanation for positive and negative and then share the notebook with all of you. Okay.
Okay, ma'am.
Yeah, because I'm myself not sure, so I don't want anybody to also to get confused. Okay. So is that fine? I don't think,
Yes, ma'am.
I think it's just a parameter, because if you see positive, if woman is to Bart, then what is to man, right? So let us do it like this. Word to vec model, woman is to queen, then a negative man is to what? Spelling king. I think this positive and negative is just a parameter. It does not hold any specific meaning or something. Okay. Because it is not giving you any negative sense, right? That man is to king, that is a positive sense only. Woman is to queen, then man is to what, right? Is it right? i'll
Okay, ma'am.
i'll check and let you know. I think these are
But
just the parameters. Let us see if we write just a and b in this place, so will it make any difference? This is like, I think, just an instance to say, okay, it got an unexpected argument. Okay, I will check and let you know on this. I think as of now it's just a parameter. Treat it as just a parameter, predefined parameter. Because if we are changing it to A and B, then the model is not taking it. Okay? Okay, then thank you all. I hope today's session was useful and you learned something.
Uh, Ma'am,
Thank
I
you,
have
ma'am.
one question.
Yes,
Thank you.
yes, thank you.
Uh, can we create a parse tree for other languages?
Yes, you can. I told you that day also. You just need to look up for specific libraries, INLTK, Indic NLP, Stanford Core NLP, and even Spacey provides support for some languages. I shared the list of the languages today. Just look into them and try to come up. That day in the previous session also I told this point.
Okay.
Yeah. Thank you so much. Okay then, thank you all for